Hey, eighth graders, last week we started talking about functions and we were determining what made a function by looking at tables. If X values repeat, we do not have a function. And also we looked at graphs and we talked about doing the vertical line test. If the vertical line that you draw goes through your picture more than one place, in more than one place, it's not a function. So today we're going to talk about, or this week we're going to talk about linear and non-linear functions. So within the word linear, hopefully you see the word line, right? So if you have a linear function, that just means that when that function is graphed, it forms a straight line. Which of these functions are linear? All kinds of graphs down here, correct? So all you have to do is identify which graphs form the straight line. So we have letter A, this one's linear. Letter B is linear. Letter C is non-linear. Letter D is it's linear, makes a straight line. Letter E and F are non-linear. And letter G is a linear function. Now, C, E, and F are functions. They would all pass the vertical line test. They're just not linear functions. Linear functions have to form a straight line when graphed. All right, now there's equations that you can identify as being linear equations. And here's some of the characteristics of an equation that's a linear equation. As long as your X and Y, you don't have to have both, you have to have at least one. If your X and Y or whatever variables are used has an exponent of 1. So if you have any number by itself, like for example, here's the number 2. Well, even though I don't see an exponent of 1, it's to the first power because 2 to the first power is 2. So as long as you don't see an exponent, that simply means that the exponents are 1. So you can have an X and a Y in the same equation. They can be on opposite sides of the equal sign, like in the first one, or they can be on the same side of the equal sign, like the second one. So these are all linear functions. The variables are all to the power of 1. Like I said, you don't have to see 2 variables, like y equals 6 is a linear function. And also x equals 6. Uh-oh, I'm wrong on that. That's not a function. I apologize. I'll take that out before I get your, send this to you. But anyway, but y equals 6 is a linear function. And then even if you have to do something like use the distributive property, since both x and y are to the first power, that is also a function. All right. Now, all of these equations are examples of non-linear. So if you have any of the variable, either of the variables that has an exponent greater than 1, so here we see x is raised to the second power. So this would not be linear. If we made a t-chart and we graphed it, it would not form a straight line. Here I have 6 times x to the third power. Since x has an exponent greater than 1, it is non-linear. Also, you have a nonlinear equation if your x or y is the exponent. So this is y equals 2 to the power of x. Well, if we made a t-chart and graphed that, we would see that that does not form a straight line. So when your variable is the exponent, it's nonlinear. And then here on the last example, if you have your x or y as the divisor or the quotient, it is nonlinear, okay? All right, now we've looked at graphs, we've looked at equations, and now we're going to look at tables. So there's a way to see if a table shows a linear function. One way, the way to figure it out is if you have a constant rate of change is what is called. So the way you find the rate of change is you think, okay, what is the change in y over the change of x? So what is happening to y? We're adding 1, and in x we're adding 1. From 1 to 2, that's adding 1. From 5 to 6, that is adding 1. And then from 2 to 3, 1, and then 6 to 7 is plus 1. So the change in y is 1, and the change in x is 1. So 1 divided by 1 is 1. The constant rate of change on the first graph is 1. But since they're all consistent, we know it's a linear function. All right, let's look at the next table. This change is plus 1, and this change is plus 4. This change is plus 3. No, it isn't. Just kidding. The top one's plus 3. I'm sorry. Let me get rid of that. All right, plus 3. And then from 1 to 2 is plus 1. From 7 to 13 is plus 6. So you might think, uh-oh, it's not linear. But from 2 to 4 is plus 2. Let's go ahead and do the whole table. And then from 13 to 16 is plus 3, and 4 to 5 is plus 1. So if we look at the first one, our change in y is 3, our change in x is 1. I can simplify 3 over 1 to 3. Well, let's look at these ordered pairs. The change from 7 to 13 is 6. The change from 2 to 4 is 2. So 6 divided by 2 is also 3. So even though the numbers are different, the rate of change is the same. So that means that this graph or this table is also a linear function. Okay, if it simplifies to be the same answer, then it's linear. Even though this changed by more than 1 and this one changed by more than 3. All right, let's see this one. How do you go from 1 to 2? You add 1. From 4 to 7, you go add 3. From 2 to 5, we add 3. From 7 to 16, we add 9. So if we put the change in y over the change in 1, we get 3. And then the second change, if we went 9, change in y is 9, the change in x is 3. That is also a rate of change of 3. So this one is also linear. Okay, so all 3 of those first tables are linear. Let's look at the last 2. All right, so our change here is from 1 to 2 is plus 1, and from 2 to 3 is plus 1. So from 1 to 4, we would add 3, but from 4 to 5, we would go up 1. So if we did a ratio of change in y over x, for the first one, we get 3 over 1. But for the second change, we would do 1 over 1, and these are not equal. So even though this represents a function, because the x values don't repeat, this is a non-linear function. It's a non-linear function. All right, and then the last one, go ahead and think of it on your own. This change is plus 3. This change is plus 3. This change is plus 15. And this change is plus 4. Whoops. So 15 over 3 is not the same as 4 over 3. So even though this, once again, this table represents a function, it is a non-linear function. Non-linear function. All righty, moving on. Now in your, I gotta take my jacket off. It's hot in here. In your problems this week, which you are of course reading, you're looking at the example problems, you're doing all the practice problems. Florida Virtual has a great lesson on graphs of functions. So I don't really feel like I need to repeat that. I just want to make sure, first of all, you should be reading and doing all the practice problems anyway. But I just want to make sure you pay special attention to the speed distant graphs and the scenarios in 4.05 graphs of functions. So I want you to read all those scenarios. I want you to do all those practice problems. Did you do all the practice problems like this one where you have to drag the descriptions for each part of the graph? If you read and do all the practice problems, you're going to do great on this section. All right. All right, so just to recap on that particular section, these are time, this would be time, and this would be speed. graphs. Most of them that I saw were time and speed, or distance and speed. So let's just review on these 3 questions. According to this graph right here, which section of the graph is increasing? Well, the only part of the graph that's increasing is part B. So to increase on a graph, you would be going up. To decrease on a graph, you'd be going down. So the next question asks, which section of the graph is decreasing? So the section of the graph that's going down and to the right is part D. And then the last question is, which section, it should say sections of the graph are constant, because we have 2 sections where constant part of the graph is going to be represented by a horizontal line. So the sections that are constant are the sections A and C. And as long as you went through your Florida virtual lesson and did those practice problems, then that means that you already understand that concept, okay? All right, you guys, well, this is it for our little practice review this week. So pretty easy, right? And this week we are going to Zoom on Thursday at 10 o'clock. I just want to see how you guys are progressing and see if you guys have any questions. So let me know. If you have any questions, you don't have to wait till the Zoom, but if you do have specific questions that might help everyone, please bring them to the Zoom meeting, okay? All right, you guys, I will check in with you soon. I hope everyone has a wonderful week.